Hello, everybody. So today we're going to talk about the difference between arc length and arc measure. We're going to really focus on using this one particular formula. I've been getting a few questions and emails and stuff about the arc length, and here's my kind of like comprehensive guide to this section right now. First and foremost, as we've been saying, arc measure is the amount of degrees on the circle. It's equal to the central angle measure. Guys, once you hear measure, angle measure, arc measure, we should know that this is in degrees, right? So as I look over on this graph here, right, on this diagram, we have circle A. We're going to assume that EB is a diameter, so it is dividing the circle in half. And they give us two angles over here. So right off the bat, I want to take a look and notice that angle, the measure of angle BAC is 30 degrees, which means arc BC has a measure of 30 degrees, right? So in the last video we sent last week, I was drawing arrows out here to point, right? So if this is 30 degrees, then the measure of arc BC is 30 degrees. If the measure of angle CAD, central angle CAD, is 45 degrees, then what arc is 45 degrees? Arc CD, right? The measure of arc CD is 45 degrees. So while we're at it here, if EB is a diameter, then we know that this whole angle here is 180 degrees. Okay? Likewise, these three angles together are also 180 degrees. So what I'm going to do here is, let's see, 30 plus 45, that's 75 degrees. That's going to leave 105 degrees over here for the measure of angle EAD. Okay? What arc has a measure of 105 degrees? Arc ED. Alrighty? So we have all of our angle measures labeled. Now that means we also know all of our arc measures. Now, one thing I want to focus on in this particular video is arc length. Okay, now length is not measured in degrees. Length is measured in feet, units, miles, meters. So what I want you to notice right here, arc length is the curved distance of the arc. So if I wanted to find the length of arc BC, I wouldn't use degrees. You know, we'll find out later. We got a little bit of measurements down here. But basically, guys, it's the length of the pizza crust. All right, so I just kind of highlighted these two here. That's the length we're going to look for. Now, we already know one particular way to find a length on a circle. So what do we call the total length or distance around the outside of a circle? It's like the perimeter of a circle. We call it circumference. Okay, so here's what I want you to notice. All right, if we are given this information here, I'm going to jump ahead a little bit. Find each of the values below if the area of the circle is 576 pi inches squared. All right, well, I want to start with that right off the bat. So as soon as they tell me that this is the circle area, just like, I've been telling you since the beginning of the year, as soon as I am given some information, I want to write my formula. So the first thing I'm going to do is I'm going to write area equals pi r squared. A equals pi radius squared. Now, this 576 represents my area. So that's going to go right here. 576 pi equals pi r squared. Now, I want to solve this equation. Now, before I even take a square root here, I'm noticing that I have pi's on each side here. So what I'm going to do here is I'm going to divide out pi on the left. What I do to one side of the equation, I'm going to do to the other. Now let me clean this up. I now have 576 equals radius squared. All right, I'm going to grab my calculator. Okay, we need to take the square root of both sides. So square root of r squared, square root of 576. Square root is r, right? Square root of 576. So I'm going to type that in my calculator. Which is nice. That gives me a nice whole number. So what I now know is the radius of this circle is 24 inches. Okay? All right. Now I'm going to jump ahead. I'm going to come down here, right? One of the first things we're asked to find is the circumference of circle A. Again, ladies and gentlemen, write your formulas. Circumference is pi times the diameter. Well, let's think about this. If the radius is 24, then what is my diameter? It's going to be 24 times 2, which is 48. So I come down here, circumference equals pi times diameter. But I just want to make sure you understand real quick. We always write the pi afterwards, kind of like a variable, although it's not. I'm going to write this as circumference equals 48 pi, and now I'm going to put my label in there. Okay? Now, ladies and gentlemen, very importantly, That is exact. All right, your exact values will always have the pi in it or just be a whole number. If we wanted the approximate, okay, I'm going to use my little squiggly, right, my approximately equal to sign. So now I'm just going to take 48 pi. Now, that gives me about, I'm going to round to the nearest hundredths, 150.796. So I'm going to call that 0.80 or 0.8 inches. All right, so just be clear, right? To be clear, exact has the pi in it, approximately, or our approximate values will be the rounded decimal. All right, so at this point in time, guys, I think it's been pretty straightforward. We found each of the angle measures, which means we found each of the arc measures. They gave us the area of the circle. We worked backwards to find our radius and diameter, and now we know the total distance around the circle, 48 pi, or about 150.8 inches. All right, we're in a good spot here, but this is where I want to focus on a very important formula, okay? Before I get to the formula, I just want you to look over here, say, for example, at 30 degrees. If I want to find the length of arc BC, now notice I'm not saying arc measure. I already know it's 30 degrees, excuse me. I want to know how many inches long it is. I want to know what is the length of that pizza crust on the outside. One thing I want to start with is this. We should all know that there are 360 degrees in a full circle. So if this little arc is made up of only 30 out of those 360, well, I want you to take a look here, right? 30 out of 360. Well, let's simplify this fraction, okay? I'm going to divide by 10, right, which will give me 3 over 36. And then if I divide both of them by 3, I'm going to get 1/12. So what I'm talking about right now is this. This little sliver right here that took up 30 degrees is 1/12 of the circle. Just going back to some earlier days when you guys were converting from decimals to percents, right? I would divide that and then multiply by 100. So basically, this is only a small part of this circle. It's only about 8.33% of the circle. Okay, I'll squeeze that in there. All right, so just to give you an idea, like this is just a portion of the circle. So here's what we're going to do. We are going to use a proportion. What we're going to do is, and this is super duper important here, guys, this is what we want to make sure we know. I'm going to say this a few times, and I need you to please listen. Theta is to 360 as arc length is to circumference. Now let me explain what I mean by that. Theta is going to be the number of degrees that we're using. So for right now, I'm going to try to find the arc length of BC. Theta will be 30. I'm comparing, look guys, part of the degrees to all of the degrees, right? 30 is to 360. Now look over here, as arc length is to circumference. This helps me understand it. Listen, part of the degrees is to all of the degrees, as part of the circumference is to all of the circumference, right? Part is to whole as part is to whole. But I want to make this a little bit more easy to write in my formula. So arc length, I'm going to use L. Okay, theta will represent my degrees. And instead of writing circumference out, I'm going to write the actual formula for circumference, pi d. One more time. Part of the degrees is to all of the degrees, as part of the circumference is to all of it. So let's go ahead and give this a shot. I'm going to be annoying with this. I want you to write your formula every single time that you use it. Theta is to 360 as arc length is to pi d. Now, if I'm trying to find the length of arc BC, do I know the arc measure or angle measure? I do. It's 30 out of 360. What are we looking for? Well, we're looking for the length of the arc length. So I'm going to leave arc length as the variable L. But ladies and gentlemen, we all know the total distance around here, right? We know the total distance around is 48 pi, pi times diameter. I'm going to keep saying it. Part of the degrees is to all of the degrees, as part of the circumference is to all of it. Now, some people leave the fraction the way it is. And you can do that. It's totally fine. But I'm going to simplify it. I just went through the process over here of simplifying that to 1/12. So here we go, ladies and gentlemen. I have forgot the pi. That's pretty darn important. So I have a fraction set equal to a fraction. This is a proportion. I'm going to cross multiply. Okay, so here we go. 12 times L, 12 times the arc length, is equal to 1 times 48 pi. Now all I have to do is divide both sides by 12, and I will have arc length equals 4 pi inches. Okay, I'm going to let that settle in. I'm just going to do 2 more examples of this, okay? And basically, guys, this is what we're going to do when we're asked to find arc length. Later in the week, we're going to have a check-in that's due, and this is the work that you're going to be expected to show. All right, here we go. The length of arc CD. Arc CD I have highlighted in yellow. Let's speed this up a little bit. Again, theta is to 360 as arc length is to pi d. All right, do I know theta? Do I know my angle measures? Yes, I do, right? I have 45 is to 360 as arc length, I don't know it, so I'm going to leave it as a variable, is to the total distance around. So guys, for this whole circle, for all of these arc length examples, it's going to be 48 pi each time, because that's the total circumference. We're basically just finding a portion of the total circumference. Now, 45 out of 360. Okay, if you want, again, you could leave it, or I noticed that they're both divisible by 9. Okay, but if you do have one of these calculators, the graphing calculators, I could do 45 divided by 360, math, enter, enter. All right, oh, so that's nice. That simplifies really nicely to 1/8, which basically means 45 degrees is 1/8 of 360, or this slice of pizza is 1/8 of the pie. All right, so now, again, I write my proportion. I'm going to cross multiply. I get 8L equals 48 pi. Divide both sides by 8, and we get L equals 6 pi inches. All right, I'm going to leave these in exact form. If you wanted to, you could type in your calculator and get a decimal. Now that brings us to our last question here, and if you notice, I have a major arc, right? These two were minor arcs with the 2 letters, but this is a major arc, okay? So this is going to be a lot of the circle. So we're going to start from D, pass through B, and end at E. So this is going to be a large portion of this circle. Okay, so if I want to find the distance around that pink curved length, right, arc DBE, well, what I want to do here is this. I know that it's 180, right? I know 180 degrees is here, but then I got to add 75 more degrees here. So I'm going to do 180 plus 75. Okay, so the arc measure, let's go back real quick. Remember, arc measure is in degrees. So the arc measure of DBE is 255 degrees, but that's not the length. Okay, so now let's go ahead and set up our proportion for the length. So again, theta is to 360 as L is to pi d. Our theta is big, all right? It's most of the circle, 255 out of 360 equals arc length, which we're looking for, over 48 pi again. Now, I'm not sure if this is going to simplify nicely, but let's give it a shot. 255 divided by 360, math, enter, enter. That's not terrible, right? 17/24. All right, let's see how this works out. Again, I'm just cleaning up, simplifying. Now I'm going to cross multiply. I'm going to get 24L equals 17. All right, now this is good for you guys on your calculator. I have to multiply 17 times 48 pi, okay? If I want to leave it exact, all I'm going to do is 17 times 48, okay? And that's 816, but I'm going to put the pi back in, right? So 17 times 48 pi, 816 pi. I'm going to divide both sides by 24. So let's see, divided by 24. Notice I'm leaving the pi out temporarily, right? Oh, nice, it works nicely. So that gives me 34 pi inches. Okay, ladies and gentlemen, to quickly recap, arc measure, degrees. Arc length, we're going to use this particular formula and use a proportion to solve. What are the components? Theta, which is the central angle or arc measure. L we're using as a variable for arc length. And pi d is your circumference. Last idea, part of the degrees is to all of the degrees, as part of the circumference is to all of it. I hope this helps, ladies and gentlemen. Let me know.